In 1980, deep in the tracking data of a lonely spacecraft billions of miles from Earth, NASA discovered something that should have been physically impossible. A spacecraft called Pioneer 10, already past Jupiter, already past Saturn, already farther from home than any human-made object had ever traveled, was slowing down. Not because anything had failed, not because anything had been commanded. It was being pulled backward, toward the sun, by a force that didn't exist in any model anyone had built.
An engineer at NASA's Jet Propulsion Lab checked the math, then checked it again. The number wouldn't go away. Here's why that should be impossible. Once you account for the sun's gravity, and engineers had, down to the decimal, a spacecraft drifting through deep space should coast in a perfectly predictable line. There is no friction in a vacuum, no wind, nothing out there to push against. This is some of the most reliable physics in existence. And Pioneer 10 was breaking it anyway. Then it got worse, because Pioneer 11, a second spacecraft, sent in a completely different direction, on its way to a different part of the solar system entirely, was decelerating by almost exactly the same amount. Two spacecraft, two different trajectories, the same impossible number showing up independently in both.
If this had happened to one ship, it would have been a malfunction, a footnote. But it happened to two. And that single fact turned a quiet engineering anomaly into one of the strangest open questions in modern physics. A question NASA could not answer, could not dismiss, and could not make go away for the next 23 years. Something out there was pulling on them, and nobody knew what it was. Here's what made this anomaly impossible to ignore. These weren't obscure probes nobody would notice if they failed. Pioneer 10 was the first spacecraft in history to cross the asteroid belt and survive. Pioneer 11 became the first man-made object to ever reach Saturn. Each one carried a gold anodized plaque, a message for any intelligence that might one day find them drifting between the stars. These were flagship missions, watched closely, expected to behave exactly as predicted. Which is exactly why an unexplained force acting on both of them couldn't just be filed away. NASA tracked them using nothing exotic, a radio signal sent to Earth, timed precisely on its way back. That single measurement gives a spacecraft's speed and position with extraordinary accuracy.
And that accuracy is exactly why nobody could explain away what the data kept showing.
NASA started with the boring explanations, because boring explanations are usually correct. A gas leak venting unevenly, acting like a faint accidental thruster. Heat from the nuclear power source escaping unevenly. A software error in the tracking signal. Each one got tested. Each one got partially ruled out. None of them fully closed the gap. By the late 1990s, physicist John Anderson ran out of patience with silence. He published the anomaly formally, gave it a name, the Pioneer Anomaly, and handed it to the entire physics community. That's when it escalated. Outside physicists stopped asking what was wrong with the spacecraft and started asking something bigger. What if nothing was wrong with the spacecraft at all? What if gravity itself, tested for centuries inside the solar system, simply bends at distances this extreme? Papers proposed rewriting gravity. Others wondered if this was dark matter, finally leaving a fingerprint humans could measure. For more than 2 decades, respected physicists treated this as a real possibility, that 2 aging NASA spacecraft had stumbled onto a flaw in Newton and Einstein both. Nobody could prove it. Nobody could rule it out. That uncertainty sat there, unresolved, for 23 years. Picture 2 boxes of old cassette tapes, gathering dust in a garage, nearly thrown away. That
that's where the answer was actually hiding.
In 2011, physicist Slava Turishev's team tracked down the original raw data on exactly those tapes, and with computing power that simply didn't exist in 1980, they rebuilt something nobody could calculate the first time around: exactly how heat left the spacecraft's power source and bounced unevenly off its own antenna. Think of it like a tiny, invisible exhaust. A spacecraft losing heat unevenly gets a microscopic push. In the silence of deep space, even that's enough to matter. And that push should fade over time in a precise, calculable curve as the nuclear fuel slowly decayed. When they ran the numbers against that decay curve, the anomaly didn't just shrink. It matched, almost exactly.
The Pioneer anomaly was not new physics. It was heat. Old, leaking sideways off the back of a 40-year-old spacecraft, finally caught by tools precise enough to see it. Sit with that for a second. For 23 years, some of the smartest physicists on Earth seriously entertained the idea that gravity itself might be wrong. Careers were built defending that idea. And the real answer had been sitting in a garage on magnetic tape the entire time, waiting for someone with the right tools to finally look. That should unsettle you a little. Not because the universe lied, but because it shows you how thin the line is between a genuine discovery and a mistake nobody had the means to catch yet. 23 years. That's how long it took to tell the difference. And the only thing that changed wasn't the data. It was the technology finally good enough to read it correctly.
Here's the part almost nobody talks about. This mistake didn't just get solved and forgotten. It rewrote how every deep space mission since has been built. Voyager, New Horizons. Every spacecraft now heading toward the outer planets carries thermal recoil modeling baked directly into its navigation, specifically because of what two forgotten Pioneer probes accidentally revealed decades ago. John Anderson, the man who named the anomaly and spent his career chasing it, died in 2014. He lived just long enough to see the heat explanation hold up, but not long enough to see the book fully closed. And here's what should actually stay with you. The exact same precision tracking that caught this anomaly is being used right now on missions at the true edge of the solar system and beyond. Which means somewhere in data being collected at this very moment, there could be another number refusing to behave, sitting quietly, waiting for someone to notice. Last time, it took 23 years for anyone to look closely enough. The only question now is whether we'll catch the next one faster, or whether it's already sitting there, unnoticed, right now.